Hey guys, welcome back to my channel, The Math Pad, and today we'll do some advanced questions for finding the area and perimeter of 2D shapes. So if you look at the first question, that says the base of a triangle is 9 centimeters, the nearest centimeter. Area of the triangle is 40 centimeters square, correct to the nearest 5 centimeters square. Calculate the upper bound for the perpendicular height of this triangle. So if we make our triangle over here, this is the perpendicular height of the base. So we know that the formula for the area of a triangle is 1/2 times base times the perpendicular height. But in this case, since they're asking us to find the upper bound of the perpendicular height, so what's going to happen is that our measurements are going to slightly change. We know that the base is given as 9 centimeters, correct to the nearest centimeter. So if we find the lower bound of the base, that's going to be 9 minus 0.5, just 8.5 centimeters. Upper bound of the base is going to be 9 plus 0.5, which is 9.5 centimeters. Similarly, for the area, upper bound is going to be, now in this case, since it was nearest centimeter, correct, the nearest centimeter, so we did 1 divided by 2, 0.5, and for nearest 5 centimeters square, we're going to do 5 divided by 2, which is 2.5. For the upper bound of the area, we're going to do 40 plus 2.5, which is 42.5 centimeters square. And for the lower bound of the area, we're going to subtract 2.5 of the area. That's how we calculate the upper bounds and lower bounds, depending on what, it's correct to, like the nearest centimeter, their significant figure, decimal place, or so on. So keeping that in mind, in our case, since we have to calculate the upper bound for the perpendicular height, that means we will use the upper bound for the area, hence 42.5, half times. And since the height has to be the upper bound, so that we will make the base lower bound. So it's going to be 8.5. So we will do 42.5 times 2 divided by 8.5. So 42.5 times 2 divided by 8.5. 10 is the upper bound for the perpendicular height, 10 centimeters. Yeah. Then question 2 is saying the scale on the map is 1 to 20,000 centimeters. The area of a lake on the map is 1.6 square centimeters. Calculate the actual area of the lake, give your answer in square meters. So if we start with converting the 1.6 square centimeters into meters, we know that 1 meter is 100 centimeters. 1 meter square is 10,000 centimeters square. So which means 1 centimeter would be 0.01 meters. Centimeter square in meters is going to be 0.0001. meter square. Okay, so to write 1.6 square centimeters into meter square, it's going to be 1.6 times 0.00, which will equal to 1 is 0.00016 meters square. Now, if you look at the scale, that's given in centimeters as well, so let's convert that into meters. So if we convert that into meters, we know 1 centimeter is 0.01. So 20,000 divided by 0.01 is going to be, wait, not divided times 0.01 is going to be 200. So 1 meter to 200 meters, 1 centimeter to now we squared it, so 1 meter square to 40,000 meters square. Now to find the actual area, I'm going to 0.0026 divided by 10,000 times 40,000. That's going to be 0.00064 meters square. So to find the actual area, what we're going to do is 1.6 times 0. Going to 0.006 times 40,000. And this is going to get divided by 0.001 because we want the final answer in square inches. So what I'm going to do is I'm going to plug this in the calculator. 2.00016 times 10,000 divided by 0.001. So that's 64,000 meters square. That is your actual area of the lake in square meters. In question 3, it says the diagram shows the front face of a barn. The width of the barn is 12 meters. The height of the barn is 8 meters, and the sides of the barn are both of height 5 meters. Work out the area of the front face of the barn. So, as you can see, this is right in the middle. So this is 6, and this is 6. We can use the area of the trapezium formula to find the area of the front face of the barn. We know that area of a trapezium has the formula of 1/2 times height times sum of parallel sides. So our height in this case is 6 and parallel sides are 5 and 8. That's 3 times 30, 39 square. Now this is just the area of one part. So total area would be 39 times 2, which is going to be 78 meters square. Then if you look at the second part, it's saying the length of the barn is 15 meters. Work out the word. So we already have the area of the front face, which is 78. The volume is basically cross section area times the height. Cross section area is 78 and height is 50. We just multiply it 2, and that will give us the area. That was the volume of this barn, which is 1,177 square. So whenever you have like 3D shapes and you've already calculated area, and they've given you the running length of the 3D object, you can easily find the volume by multiplying the cross section area with that. Then if we go to the next question, it says that a helicopter flies 8 kilometers due north from A to B. It then flies 5 kilometers from B to C, and then returns to A from C, and the angle ABC, so the angle at E is 150. Calculate the area. So if you would remember from our previous videos where we discussed finding the areas of non-right angle triangles, the formula we used was 1/2 times AB times sine of angle C. So basically, this formula is applicable when we have a triangle, non-right angle triangle. And in that non-right angle triangle, what we have is two lengths and the angle between them, which is applicable over here. The two lengths are 8 and 5. And the angle between them is also given, which is 150. So we do 1/2 times 8 times 5 times sine 150. So that will equal to 10 kilometers square. Then if you move on to the next part, it says find the bearing of B from C. Since it says bearing of B from C, so we make the compass axe. Like whichever it is, like saying, it's from that point, compass. So what do we have? We can find this angle by doing 180 minus 150, which is 30. So this is 30. And we know that in parallel lines, alternate angles equal to each other, which means this entire thing would also be equal to 30. So if we're trying to calculate the bearing of A from C, we need this. So that means we need to find the angle over there. Yeah. Oh, bearing of B from C, not A from C. So yeah, then we just add this to bearing would be 180 plus 30. Always remember that the bearing is calculated in a clockwise direction from the north of the point, like from which you're finding the bearing, and you go clockwise towards the line where the other point is located. So when we went from the north of point C clockwise direction, this is where B is till this line. So that means 180 plus this 30 is going to be 210. And your bearing is always written in 3 digits. So if it was like, if let's the bearing was given as 30, then you would write it as 0. Then question 5 is since diagram shows a square of size k centimeters. The circle inside the square touches all 4 sides of the square. the shaded area is a centimeter square, so that 4a equals to this. So area of square would be k times k, which is k square. Area of circle would be pi k by 2 square. The reason why the radius is k by 2 is k is the entire length. That's the diameter. Diameter over here is k. That means the radius would be k by 2. That basically becomes k square times pi over 4. So shaded area would be a square minus a square pi over 4. And the shaded area is denoted by a. So we write a equals to k square minus k square pi over 4. Multiply all the terms by 4 to get rid of the fraction. So it becomes 4a equals to 4k square minus k square pi. And that's exactly what the equation is. Question. Then in part B, it's saying make k the subject of the formula. So what I'm going to do is I'm going to remove this. So we have 4a equals to 4k square minus k square pi. So we have to make k the subject. So what I'm going to do is I'm going to take k square common over here. And in the brackets, we're going to have 4 minus pi. And I'm going to divide 4a by 4 minus pi. And isolate k square over here. Now I'm going to take the square root on both sides, which gives me a square root of 4a over 4 minus pi. Now, as you all know, when you take the square root of a number, we get a positive and negative value. We will only use the positive value in this case because k represents the length of the square. And the length of a square or any shape, as a matter of fact, it cannot be a negative term. So since the length is always positive, so we disregard the negative square root of this and only focus on the positive. And question 6 is saying ABCD is a trapezium. Find the area of the trapezium in terms of x and simplify around. So as you know, area of a trapezium is 1 over 2 times the height times the sum of parallel sides So our height is given as 5x. Parallel sides are 13x and 29x. So I'm going to do 1 over 2 times 5x times 13x plus 20. That's going to be 1 over 2 times 5 2x. So 5x times 1x and 6x squared. That is our area of the trapezium in terms of x. And I don't think we can simplify this further, so that would be our A. Then if we move on to the next part, angle BCD is y degrees. Calculate the value of y. So, okay. For that, we know that we can use SOHCAHTOA for this. And we know that for SOHCAHTOA, we first show we need the opposite and the hypotenuse. In case you've missed out on that video, the diagonal is always the opposite. Sorry, the diagonal is always the hypotenuse. The line on which the angle lies is adjacent, and the line opposite to the angle is called opposite. So keeping that in mind, what we have is the opposite and the adjacent. So I'm going to go for tangent. Tan y equals to 5x over 12x. In case you're wondering, we have two unknowns in this equation. But if you notice, 5x is divided by 12x, which means the x's get cancelled out. And what we have is tan y equals to 5 over 12 now. So we take tan inverse of 5 divided by 12. And that is going to give us 32.6. That is your value. Lastly, if you look at question number 7, we have this non-right angle triangle. We have been given 3 measurements, like the measurements of the length of the triangle, and we have an angle. We want us to calculate the area. As you know, we do area equals to 1 over 2 times 12 times 8. The reason why I chose 12 and 8 is because we need 2 lengths and the angle between them. So that's applicable on 8 and 12 because we have the angle times sine 26 point. Just plug it in the calculator. 12.8 times sine of 60. 20, sine of 26.4, sorry. And divide the result by 2. 21.3 centimeters squared. If you have any questions or confusions about any of these, let me know in the comments below and I'll help you out.